Hello, so this is part 19 and I'm gonna do the unit test for rates, proportions. Yeah, okay. Oh man, I don't have any practice or anything. Oh crap, am I ready for this? Let's just go. Holy shit, there are 4 questions, okay. Okay. No, I saw this yesterday. Susan plants her tomato plants in rows. Susan plants her tomato plants in rows. The double number line shows that she plants 8 tomato plants in one row. Wait, what? Oh, yo, it's sick. Oh my god, my saliva or something. Oh my god, I'm disgusting. The double number line shows that she plants. Alright, so just whatever. Oh my god, I don't want it to make a mistake. Because just one mistake, I'm gonna redo the whole thing. Oh my god. Plants per row. So this is 1 to 8 ratio. Okay, so multiply by 8, multiply by 32, multiply by 8, no. Multiply by 8, 64, 50, 11, okay, cool, B. Elio makes candles that are 14 centimeters tall. Each candle burns 8 hours before going out. He is wondering how many hours a 21 centimeter tall candle can burn for. No shit, it's insane for a second question. Okay. How long? Okay, so we're looking for the hours. Let's say 21x. This pretty much same with the other one, right? So this is R centimeters. So just cut the bullshit. Oh, this is 7.3, 7.2. So cancel that bullshit. And this one we get nothing divided by. So we get 4, 12. Run for 12 hours. Oh yeah. Cool. Ah, crap, this is insane. Handsome Jack spying a pony made of diamonds. The price of the pony is $P. Jack also has to pay 25% diamond pony tax. Oh, okay. He's buying a pony made of diamonds. The price of the pony is $P. Jack also has to pay 25 diamond pony tax. Sorry, so 1.25. So P plus 0.25. This would work. And let's see. This is just 1.2 or 1.25. So we could actually write this as 1 and 1/4. So this is 1 and 25. Okay, that's gonna work. So let's see. This is clearly not working. Let's do things. No. No, no. And CP plus 1/4 times P? No. Okay, cool. The diagram shows the ratio of trees Maev plants to the trees she harvests. Okay, it's 5:2. The table shows a number of trees Maev planted and harvested in 2 days. This is for 2 days. Cool. Wait, what? Day Wednesday? How much? What is this original day? Oh, okay, so I don't need to know. It's actually 18 over here. If that's 80, this is multiplied by 9, so I'm gonna multiply this by 9. So we have 45 over here. So I guess it's multiplied by 11, so we're gonna 22, right? Oh shit, I could be wrong. Let's see. I don't want to make a mistake, so this is clearly 5:2 ratio. So if our guy times 9 to 18. And 45 times 9 is 4. And times 5 is 45. And from 2 to become 22, you get 11. So times 11, 1, 2, 3, 4, 5 times 5, 22. Oh my god, I'm getting so paranoid right now. 11. Okay, but I'm sure about that. Cool. God damn it. Double number line shows that 4 pounds of almond cost $34. Based on the ratio, what is the cost for 5 pounds of almonds? Okay, sure. So, let's see. If we divide 34 by 4, so we get 8 and 32. We have 20 and then 5. 20, 0, 8.5 times, oops, 8.5 times 5, we got 25 to 42, man. You're gonna do 42.5, man. 42.5. But of course, to be sure, why don't this quiz give me a freaking calculator, please? Okay, let's try again. 34 divided by 4. We're gonna have 8, and it's gonna be 32. We have 20. Bring down 0. We have 20. 8.5. Okay, cool. 8.5 does work. Okay, 42.5, it should be correct. God damn it. This makes hearts pounding. Am I really recording though? Okay, cool. Only 7 minutes in. Wow. A baker has 3 banana muffin recipes. Recipe A uses 3 bananas to make 12 muffins. Recipe B uses 5 bananas to make 24 muffins. Recipe C uses 11 bananas to make 48 muffins. Order the recipes by number of bananas per muffin, from least to greatest. Okay. Oh, cool. Calculate. Number of bananas. So it's banana per muffin. So this one's 0.25. B is like 5 divided by 24. 0.2. 11. To 3 for C. So we actually have A is the biggest, and C. A is least. B, C, A. I mean, does this make sense? It could be the other way around. I could make a mistake. Okay. Now let's do this again. What if we do 12 divided by 5? Actually by 4. And 24 divided by 5. No, this is the other way around. This is muffins per banana. See, so we need bananas per muffin. a 5 divided by 24. 0.2 11 divided by 48. Okay, so BCA. Bananas Whew. During each minute of her comedy show, Carlin laughs 5 times. During a minute of a comedy. Carlin watches 3 comedy shows every day. Each show is 4 minutes long. Okay. So each show is 40 minutes long and 3 or 5. So 40 times 5 times 3. 600 laughs. The table shows a proportional relationship between the number of pounds of bananas purchased and the total cost of bananas. Proportional relationship. Okay. So let's see. If we divide 1.47 by 3, okay, 0.49. We should get 0.49 for every one of these. 2.45 divided, or this 0.5. Wow, 0.49, cool. 4.41 divided by 9. 0.49. Okay. Let's see 3 answers. Dollars 0.98 divided by 2 is 0.49, obviously. And we have 4.45 divided by 7. Nope, no siree. 2.94 divided by 6. Okay. No, it's gonna be the same thing if it's divided by 1. So I guess 3.92. The following table shows the speed that I'm. Just gonna grab my coffee. Oh yeah, coffee. I love coffee. Snail. Just 2, so no. I'll say caterpillar. Is 7? Oh, this is 1. So I guess the ant. But of course, to be sure. Oh. Wait, what? Oh no. Oh fuck, I made a mistake. I made a mistake with my calculations. Which should be 12 divided by 8. 4. 5. Okay, 4. It's the ant. But anyway, if we do 4 divided by 8, it's gonna be 0.5. The table shows Jace's earnings based on the number R sure. 2030. No. A pink crayon is made with 12 milliliters of red wax for every 5 milliliters of white wax. Which of the following wax mixtures will create the same shade of pink? Okay, so let's see, two answers. It should be the same ratio of 12 to 5. White wax. So if you divide it by... You don't have any column because this one's already prime. Let's see. Divisible by 5, let's see. 15 is... So times 5. Just go to 3. Times 3 is 36. 36, okay. Times 5, 5 times 5 is 25. 12 times 5 is 60 as well, so cool. This two would work. Just to confirm the other ones? No. Okay, times 3. 15 times 3, 36. 25 times 5 is 25. 12 times 5 is 60. Cool. The table shows the number of animals by type at a petting zoo. Select the true statements about the information in the table. Oh my gosh. Okay, so there are a total of 16. 5, 3 to 10, 16. Okay. The ratio of cows to all animals is 1 to 16. Cows is 2. No. It's 2 to 16. For every 3 rabbits, there are 8 total animals. 3 rabbits. That's true. That's true. Because the rabbits are 6 to 16. And then divide it by 2, you get 3, and then you get 8. Okay. None of the above. Okay, so this one, the only thing that applies. Yeah. No other, any other? Okay. Woo! Of a number is what percentage of that number? Yo, what the fuck is this? Okay. 22 over 25 of a number is what percentage of that number? So multiply by 4, 100, multiply by 4, get 88. And to be sure, because I'm an idiot, cool, 88%. Oh man, 15. Halfway. Almost halfway. Jackson bought 5 ounces of raisins for $4. How much do raisins cost per ounce? Okay, so the 5 ounces of raisins cost 5 ounces of raisins for $4. So we're gonna divide it by 5 to get the same amount, $0.8, 0.8 per ounce. How many ounces of raisins can be for $1? Okay, so 5 divided by 4, 1, 4, 1, then 0, you get 2, 8, 220, 1.25 ounces, bro. Yo, I'm quite sure this is correct, but of course, we're in a unit test. We're gonna double test shit instead of making a bonehead mistake and repeating the whole process. How much do raisins cost per ounce? So 4 divided by 5, 1 ounce, right? So we're gonna do. So we got 40, Yep, 40. So we need 8 of that. Okay. And let's do the other way around. How many ounces of raisins can be bought for $1? So okay. 5 divided by 4. 1, 4, 1, 0, 2, 8, 25. Okay. This is making me insane. Select two ratios that are equivalent to 6 to 10. Okay, 6 to 10 is also 3 to 5. So let's see, from... No. This is possible, so this is times... No, not really. 6 times 6, 36. 6 times 5 is 30. So no. So this one works. Select two answers. 24 by 4. Okay, this one works. 6 times 4 is 24, and 10 times 4 is 40. The following diagram describes the number of days Zane bikes to school and the number of days Zane walks to school. What is this? 1, 2, 3, 4, 5, 6, 8 to 6, or 4/3, 4 to 3. What is the ratio of Zane bikes to days he walks? The graph shows the relationship between the length of time Ted spends knitting and the number of scarves he knits. What does 16 mean in this situation? X, Y, R's. The length of time Ted spends knitting and the number of scarves he knits. So R's is times and X is, or X has the number of scarves. It's pretty much there. Ted has to knit 16 scarves now. Ted knits 16. No, it takes Ted 16 hours to knit a scarf. Yep, that's pretty much it. 16 Y is pertaining to hours. No. No. Okay. Okay, what's this? Callan goes for a hike every Saturday. Callan hikes at a rate of 3 miles per hour. Okay. I guess it's multiplied by 3. Times 3 times 3, 9 times 3, 15. Mm, 3, 9. And 5, 15. X is R, so 1. And miles, Y, 3. And 3, X, 9 miles, Y. 15X and 15Y. Okay, cool. What is the constant of proportionality? For real? It's 5/4. Is this a strict question? Yo. This is a trick. This is just 5/4. Whatever, man. Ah, cool. It takes 22 minutes for 10 people to... Oh my god, this is fucking bullshit question. Oh, but at least this one says, like, same shit, so 22 minutes. Still. I mean, just to be sure. 20 divided by 10 is 2.2 times 10 is 22. So, oh yeah, it's the same 22 minutes. Each square below represents one whole. What percent is presented by the shaded area? 150%. What percent is represented by the shaded area? 150. Please be correct. Cool. On Monday, Florencia's hair was 8 centimeters long. She got a haircut on Tuesday, so her hair was only 75% of the length. It was on Monday. Which of the person could represent how many centimeters was after the haircut? So it could be h minus 0.25 h or 0.75 h. Let's see if we got this. This is not this 0.25. This is the hair she lost. This is same shit. This is actually 7.5. Actually no, 75. Same shit. No. Two answers. Oh, we got 0.75h. Cool. Or 3/4, which is the same as 75. Cool. So what's this? 1/4. No. H minus 25h. Okay, cool. I mean that's like 1. So it's still 0.75, and 3/4 is also 0.75. Corey is hiking up a hill with a constant slope. The double number line shows that after Corey hikes 3 kilometers, his elevation is 120 meters. Select the double number line that correctly labels Corey's elevation after hikes 1 to 4 kilometers. Okay, so 3, 120, constant slope. Okay, so this is like 1/40, right? 480. Okay, cool. So 140, 280. Oh, this works. What's this? 83. No. Which line is a constant of proportionality between y and x of 4/3? So y is 4. Y is 4. Let's see, thirds. Okay, b. It's actually b. So yeah, let's see. X, or just divide both sides by x. X. Okay. Y. Am I supposed to think of it like that? I could be wrong. Although I'm pretty sure that's how Sal explained it to me. Oh my god. Should I risk this question? Anyway. Y for 3. It's B. I mean, the other ones isn't even applicable. It doesn't even go to 4. It doesn't go to 4, but it's actually 1. So it's B. Joel is working on a school report in a word processor. She wants to place an oversized image of... Oh, I remember this. Let's see. 30.51 minus 21.59. We're gonna have 11 we can have 14. We have 10, 9, and 2. We got 2 over here. What's this? 9? Yep. 0.9 minus 1, 8, 8.92. Okay. And 8.92 divided by 2. We got 4, 8, 0, 9, 2. We have 8, 1, 12, 4. Oh, what do you mean 4? Not 4. 6, and then 0. Okay. Whew. Joe's working on a school report. She wants to place an oversized in which in the program horizontal. Positions to the right of the leftmost edge are positive. So we're gonna go there and see the negative answer. 21.59. This becomes 11. This becomes 14. This becomes 9. Die. For real? It's 10, 11, 2, 9, 8, 11, 10, 15, 10, 30, 51. Okay, so 8.92 is definitely correct. And we divide that by 2. So that's the excess. If we do negative of that, then so but we need only half. Okay, so 4, 8, 0, 9, 4, 8, 1, 12. Four, 8, 0, 9, 4, 8, 1, 2, then 6, 12. Oh, 4.46. Okay, I'm quite sure this is right. So 8.92 is actually correct. And then if divided for the last time, please, for the last time, just to be sure. This is correct. 4, 8, 4, 8, 1, 12, 6, 4, 6. Please be correct. So good. Okay, what's this? 8 more questions. Oh, cool. This one's easy. Each fixing represents one whole. What percent? 160%. 1, 2, 3, 4, 5, 6. Let's not be hasty. That's 40% missing. Cool. The square below represents one whole. Express the shaded area as a fraction decimal percent in the whole. So as a fraction, this is 98 over 100. Decimal 0.98, and percent is 98%. Let's just correct again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 100 minus 2 is 98. A fraction, 98 over 100. Am I supposed to simplify this? Doesn't ask for simplification, so I guess it can work. Whew. The audience thinks 30% of Brandon jokes are funny. What fraction of Brandon jokes does the audience thinks are funny? 3 over 10. It's 30%. Simplified. Okay, let's simplified. I mean, 3 is already a prime. So 30% is the same as 30 per 100. Then you remove both 0. We have 3 over 10. And we can simplify that and do further. Four more questions. Actually, 5. This is the. Yuki bought a pound of confetti for $12. What is the price in dollars per ounce of confetti? Wait, what? There are 16 ounces in 1 pound. What is this? A pound of confetti. 1 pound of confetti for 12 ounce for $12. What is the price in dollars per ounce of confetti? There are 16 ounces up in 1 pound. So we have 16 ounce $12. $12. So there are 16. What is the price in dollars per ounce? So we're just gonna do 12 divided by 16. Let's just do 7, 2, 4. Okay. Seems pretty close. 7. Just to be sure. I guess this is by 5. Yep. Should be 12 divided by 16 though. Yo, what the fuck? This is weird. This is so simple, like we only have a pound of confetti for 12 hours. This is literally 12 divided by 16 to get this dollar. But if I do the conversion bullshits, like 1 pound, 1 LB, I mean, I guess it's $12. Then we want this in ounces, right? So we literally have this thing. It's 4 times 3 and this is 4 times 4. We can just remove that. And you have 4 over 3 and then 4 divided by 3 is 1, 3, 1, 10, 3. Oh shit. Let's do a reality check instead. I mean, if this is, let's say, there, you bought a pound of 16 of a confetti for $12. How much in per ounce of confetti? There are 16 ounces in 1 pound. So if you multiply 0.75 by 16, we should get 12. Yeah, if this is much more larger, then it's not 12. But still, man, why? If I did a conversion, man. Okay, I'm using it wrong, obviously. But that's how we do it in my head, though. Oh, we have like 1 pound, right? 1 pound per what? We have 12 per pound. Or maybe because this is not really per. Not really, not really. Per. What is the price? I mean, if you convert this to 16, just multiply it by 16, so we have 16 ounces per $12. Let's see. Oh, let's see step solution. Oh shit, of course I could do 16 to 12. Just 4 to 3. Oh wow, cool. Oh, I'm actually quite fine with this. 16 over 12. I'm not supposed to divide this because this is a ratio, so this is 16 Right, so divide both sides by 16, we get 1 ounce, 1.75. Oh, that makes sense. Which of the following options have the same value as 2% of 90? This is 20%. Alright, this is 2%. Okay. Neil's mom makes chocolate milk with 30 ml. Oh, okay. Okay, cool. More chocolatey. Who's more chocolatey? Let's see, if we multiply this by 5, we get 150. If we multiply this by 2, we have 130. So Neil's mom's chocolate is much more chocolatey. Let's see, it's 32, right? And then we have 65, 5. So we need a common number of milk. So common denominator is 10. We multiply by 2. 130. 10. 10 by 5. 150. 16, 90, 120, 150. Right, that makes sense. Neil's mom is the 30 guy. Alright, okay. Let's see. Answer that. Okay, the same bullshit I did. Wait, no. 2 1/2. This explanation is so weird. And now she's using mom's ratio? Where do you get this 2 and 1/2? Neil's dad ratio has 2.5 times the amount of milk. What? I'm confused. What is this 2.5 times? What the fuck? Then it's applying that to mom's ratio. Oh, it's this, I guess, the 2. Amount of milk. This is the milk. So 2 and 2 times 2 and 1/2. It's gonna be 5. So, okay, it's a bit confusing. Okay, I get it. Which relationship is the same constant of proportionality between... Oh my god, I'm gonna make a mistake here. Let's not fall for the same bullshit trick. This is the same as y equals 9x. This is the same. This is the same. 9x to 18x, divide both sides by 18. I by 2, so you have 1, 9. Okay. And let's see, what's this one? X is 1. We could do like y over x equals 9 as well. So if we have 9y divided by 1 equals the same as 9 still. So this would work as well. 1x and 9y. Okay, cool. No. This is 9. Oh well, our concept proportionality is 9. Okay. So let's see, what's this? What's this? If our x is 9, 9 and 1. No. This point something. Just not gonna work. So if our x is 2 and their y is 18, yo, I'm getting 9. But let's see. 27 divided by 4, no, 36 divided by 6 is 6 still. Okay, so these guys are not correct at all. The equation 3y describes a proportional relationship where y equals 9 when... Oh, okay, so if x is 1, 27, then we'll left it 3 divided by 9 y. Wait, what? Okay. Final boss. What is this? The quantities x, y are proportional. No shit. Okay, so let's actually try to solve for one of these. So y is equals to 1/4 times 32. So we have 32 divided by 4 with 8. Y equals 8. Okay, that makes sense. Yes! I didn't make a mistake. Ugh. Feels good, man. Feels good. I'm so glad it took time to make sure I'm not making a mistake here. Feels good, man. Do CSS effects. Oh yeah. Mastered. Oh, it's amazing. How long did that took me? It took me almost an hour. Supposedly it should be like 36 minutes only. It's insane. It's because I also looked at how they solved it. That's worth it. It's worth it instead of doing all the shit. Hey, cool. So we have 100% for that one. Now we can do equations, expressions, and inequalities. Cool. What is this? What is a variable? Okay. Recording, right? Okay. Let's see. Intro to variables. What is it? Variable.
Let's say that I'm working in a restaurant and I'm making $10 per hour, but on top of my hourly wage, I also get tips each hour. So this entire expression, you can view this as how much I might make in a given hour. Now, you might also be working in a restaurant and I'm making $10 per hour, but on top of my hourly wage, I also get tips each hour. So this entire expression, you can view this as how much I might make in a given hour. Now, you might also realize that the number of tips or the amount of tips I might make in an hour can change dramatically from hour to hour. It can vary. 1 hour, it might be lunchtime, get a lot of tips, people might get some big ticket items. The next hour, I might not have any customers, and then my tips might be really low. So the tips part right over here, we consider that, the entire word, we consider that to be a variable. From scenario to scenario, it can change. So for example, in one scenario, maybe it's lunchtime, I'm getting really big tips. So tips is equal to, let's say it's equal to $30. And so the total amount I might make in that hour is going, we can go back to this expression right over here. It's going to be 10 plus, instead of writing tips here, I'll write 30 because that's what my tips are in that hour. And so that is going to be equal to, it's going to be equal to 40. Let me do that. Let me do that yellow color. It's going to be equal to $40. But let's say right after that, the restaurant slows down. We're out of the lunch hour for whatever reason. Maybe the restaurant next door has a big sale or something. And so the next hour, my tips go down dramatically. My tips go down to $5 for that hour. Now I go back to this expression. The total I make is my hourly wage plus the $5 in tips, plus the $5 in tips, which is equal to $15. As you see, this entire expression, the 10 plus tips, it changed depending on what the value of the variable tips is. Now, you won't see whole words typically used in algebra as variables. we get lazy. And so instead, we tend to use just easier to write symbols. And so in this context, instead of writing tips, maybe we could have just written 10 plus t, where t represents the tips that we get in an hour. And so then we would say, okay, what happens when t is equal to 30? Well, if t is equal to 30, then we'd have, let me write, so what happens when t is equal to 30? Well, then we have a situation, t is equal to 30. This evaluates to 10 plus 30, which would be 40. What would happen if t is equal to 5? Well, then this would evaluate to 10 plus 5, which is equal to 15. Now, I want to be clear, we didn't even have to use t. We didn't even really have to use a letter, although in traditional algebra, you almost do use a letter. We could have written it as 10 plus x, where x is your tips per hour. X might not be as natural. It's not the first letter in the word tips. Or you could have even written 10 plus star, where you could say star represents the number of tips in an hour, but it just might have not made as much intuitive sense. But hopefully this gives you a general idea of just what a variable is. All it is a symbol. All it is a symbol that represents varying values, and that's why we call it a variable. A symbol that represents varying values, and that's why we call it a variable. We now hopefully know a little bit about variables, and as we covered in the last video, a variable can be really any symbol, although we typically use letters because we're used to writing and typing letters, but it can be anything from an X to a Y, a Z, an A, a B, and so oftentimes we'll start using Greek letters like theta, but you can really use any symbol to say, hey, this is going to vary. It can take on multiple values. But out of all of these, the one that's most typically used in algebra, or really in all of mathematics, is the variable x, although all of these are used to some degree. But given that x is used so heavily, it does introduce a slight problem. And the problem is, it looks a lot like the multiplication symbol, or the one that we use in arithmetic. So in arithmetic, if I want to write 2 times 3, I literally write 2 times 3. But now that we're starting to use variables, and if I want to write 2 times x, well, if I use this as the multiplication symbol, it would be 2 times x, and the times symbol and the x look awfully similar. And if I'm not really careful with my penmanship, it can get very confusing. Is this 2xx? Is this 2 times something? What exactly is going on here? And because this is confusing, this right over here is extremely confusing, and it can be misinterpreted, we tend to not use this multiplication symbol when we are doing algebra. Instead of that, to represent multiplication, we have several options. Instead of writing 2 times x this way, we could write 2 dot x. And this dot, I want to be very clear. This is not a decimal. This is written a little bit higher, and we write this so we don't get confusion between this and one of these variables right here. But this really can be interpreted as 2 times x. So for example, if someone says 2.x, what is 2.x when x is equal to 3? Well, this would be the same thing as 2 times 3 when x is equal to 3. Another way that you could write it is you could write 2, and then you could write the x in parentheses right next to it. This is also interpreted as 2 times x.
Or just
Once
2x.
again, so if in this situation x were 7, this would be 2 times 7, or 14. And then the most traditional way of doing it is to just write the x right after the 2. And sometimes this will be read as 2x. But this literally does mean 2 times x. And you might say, well, how come we didn't always do that? Well, it would be literally confusing if we did it over here. If we just wrote, instead of writing 2 times 3, we just wrote 2, 3, well, that looks like 23. This doesn't look like 2 times 3, and that's why we never did it. But here, since we're using a letter now, it's clear that this isn't part of that number. This isn't 20-something. This is 2 times this variable x. So all of these are really the same expression. 2 times x, 2 times x, and 2 times x. And so with that out of the way, let's try a few worked examples, a few practice problems, and this will hopefully prepare you for the next exercise where you get a lot of chance to practice this. So if I were to say, what is What is 10 minus 3y? And what does this equal when y is equal to 2? Well,
Wow, it's gonna be
every time you
4.
see the
10
y, you'd
minus
want
6
that
is
2
4.
there. So this is when y is equal to 2. Let's set that y equal to 2. This is the same thing. This is the same thing as 10 minus 3 times 2. You do the multiplication first. Multiplication takes precedence in order of operations. So 3 times 2 is 6. 10 minus 6. 10 minus 6 is equal to 4. Let's do another one. Let's say that we had, I don't know, 7x minus 4, and I'm doing that same green color. 7x minus 4, and we want to evaluate that when x is equal to 3. Where when we see the x, we want to put a 3 there. So this is the same thing as 7 times 3. 7, and I'll actually use this notation because I can use that with numbers. 7 times 3 minus 4. And once again, multiplication takes precedence by order of operations over addition or subtraction. So we want to do the multiplying first. 7 times 3 is 21.
17.
21 minus 4 is equal to 17. So hopefully that gives you a little bit of background. I really encourage you to try the next exercise. It'll give you a lot of practice on being able to evaluate expressions like this.
A local hospital is holding a raffle as a fundraiser. The individual cost of participating in the raffle is given by the following expression: 5t plus 3, or 5 times t plus 3, where t represents the number of tickets someone purchases. Evaluate the expression when t is equal to 1, t is equal to 8, and t is equal to 10. So let's first take the situation where t is equal to 1. Then this expression right over here becomes, and I'll use that same color, it becomes 5 times 1 plus 3. 5 times 1 plus 3. And we know from order of operations, you do the multiplication before you do the addition. So this will be 5 times 1 is 5 plus 3. And then this is clearly equal to 8. Now let's do it when t is equal to 8. So when t is equal to 8, this expression becomes, and I'll do the same colors again, 5 times 8 plus 3. Same color of green, plus 3. And once again, 5 times 8 is 40. And then we have the plus 3 there, so this is equal to 43. And so we have the last situation with t is equal to 10. I'll do that in blue. So we have 5 times 10. So 5t is 5 times 10. Instead of a t, we put a 10 there. 5 times 10 plus 3. That's a slightly different shade of green, but I think you get the idea. 5 times 10 is 50. We do 50, and then we're going to have to add 3 to that, and that is equal to 53. And we're done.
Now let's think about expressions with more than one variable. So say I had the expression a plus, I'll do a really simple one, a plus b. And I want to evaluate this expression when a is equal to 7 and b is equal to 2. And I encourage you to pause this and try this on your own. Well, wherever we see the a, we would just replace it with the 7. And wherever we see the b, we'd replace it with the 2. So when a equals 7 and b equals 2, this expression will be 7 plus 2, which of course is equal to 9. So this expression would be equal to 9 in this circumstance. Let's do a slightly more complicated one. Let's say we have the expression x times y minus y plus x. Plus, actually let's make it plus 3x, or another way of saying it, plus 3 times x. So let's evaluate this when x is equal to 3 and y is equal to 2. And once again, I encourage you to pause this video and try this on your own.
Okay, let's see. 6 minus 2, 4. 4 plus 9. Yep, it's 13.
Well, everywhere we see an x, let's replace it with a 3. Every place we see a y,
13.
let's replace it with a 2. So this is going to be equal to 3 times y, and y is 2 in this case. 3 times 2 minus 2 plus this 3 times x, but x is also now equal to 3. So what is this going to be equal to? Well, this is going to be equal to 3 times 2 is 6. This 3 times 3 is 9. So it simplifies to 6 minus 2, which is 4, plus 9, which is equal to 13. So in this case, it is equal to 13. Let's see if we could give ourselves some practice evaluating expressions that have two different variables in them. So let's see.
Oh, wait a sec. I'm gonna go B. Okay, I'm back.
See if we can evaluate the expression 7j plus 5 minus. We could give ourselves some practice evaluating expressions that have two different variables in them. So let's see if we can evaluate the expression 7j plus 5 minus 8k when j is equal to 0.5 and k is equal to 0.25. So why don't you try to pause the video and evaluate this first before we work through it together. Alright, so if we want to evaluate this thing, everywhere we see a j, we want to replace it with a 0.5, and everywhere we see a k, we want to replace it with a 0.25. So let's do that. This is going to be 7 times, and instead of j, I'm going to put a 0.5 in there, and then we have plus 5 minus 8 times k, and k we're saying is 0.25. 0.25. So what is this going to be equal to? So if I were to take, and I can color code this, 7 times 0.5, half of 7, that's going to be 3.5, 3.5. Then I have plus 5. And then I'm going to subtract. I am subtracting 8 times 0.25. 0.25, this is 1/4. I could rewrite this if I want. 0.25, that's the same thing as 1/4. 8 times 1/4, or another way to think about it is 8 divided by 4 is going to be equal to 2. So this whole thing over here is going to be equal to 2. So it's going to be minus, we have this minus out here, so minus 2. And what is this going to be? Let's think about it. 3.5 plus 5 is 8.5. Minus 2 is going to be 6.5. So
Yeah,
this is equal
I
to
only
this
got
is equal to
1.5 because I didn't
6.5.
add the 5.
Let's do another one of these.
6.5.
All right. And just like before, try to work through it on your own before we do it together. All right, now let's do it together.
1/4.
So over here I have this expression 0.1m plus 8
3
minus
6
12n when
plus
m
8 is
is equal to 30 and n is equal to 1/4. All right, so everywhere I see an m, I want to replace with a 30, and everywhere I see an n, I want to replace with a 1/4. So this is going to be equal to 0.1 times m. M is 30 times 30 plus 8 minus 12 times n, where n is 1/4. N is 1/4. So what is 1/10? This right over here, 0.1, that's the same thing as 1/10 of 30. Well, 1/10 of 30, that's going to be 3. So this part is 3. We have 3 plus 8, and then we're going to have minus. Well, what is 12 times 1/4? That's going to be 12/4, or 12 divided by 4, which is going to be equal to 3. And now when we evaluate this, so that is equal to this, we have a 3 plus 8 minus 3. Well, 3's are going to, you have a positive 3, and then you're going to subtract 3, and you're just going to be left with, an 8. And you're done. This expression, when m is equal to 30 and n is equal to 1/4, is equal to 8.
Total failure. Okay. Evaluating expression with one variable. A plus 4 when the first. Okay. Spot. Okay, cool. So the expression. A plus. This thing is when a sub 9. Multiplication. 15. New ways to show multiplication. Yeah, so yo, you already expressed a dot over here. Three is 14 plus 5. Wait, what? 12, 17. First 17. When d equals 4 to 5. Oh wow, okay. 5 times 5 is 20. Oh, this is just 0, man. This is just 0. 2x, 8, and next article.
Now let's think about expressions with more than one variable. So say I had the expression a plus, I'll do a really simple one, a plus b. And I want to evaluate this expression when a is equal to 7 and b is equal to 2. And I encourage you to pause this and try this on your own. Well, wherever we see the a, we would just replace it with the 7. And wherever we see the b, we'd replace it with the 2. So when a equals 7 and b equals 2, this expression will be 7 plus 2, which of course is equal to 9. So this expression would be equal to 9 in this circumstance. Let's do a slightly more complicated one. Let's say we have the expression x times y minus y plus x plus, actually let's make it plus 3x, or another way of saying it, plus 3 times x. So let's evaluate this when x is equal to 3 and y is equal to 2. And once again, I encourage you to pause this video and try this on your own.
Wait, what?
Well, everywhere we see an x, let's replace it with a 3. Every place we see a y, let's replace it with a 2. So this is going to be equal to 3 times y, and y is 2 in this case. 3 times 2 minus 2.
Yeah, this is
plus,
the same bullshit video earlier.
Plus this 3 times x, but x is also now equal to 3. So what is this going to be equal to? Well, this is going to be equal to 3 times 2 is 6.
Kind of
this 3 times 3 is 9.
I hate it.
So it simplifies to 6 minus 2, which is 4, plus 9, which is equal to 13. So in this case, it is equal to 13.
Yeah, it's equal to 13. About external two variables, same on the equivalent. 10 to 0 function to another value p and r for example appear. So okay, so we have 2 times 4, 8, 15, 15 is 3. Okay. Makes sense. Equals 3 when okay. let's see. A is 1 and B is 3. So 6 plus 12. This is 12. X is 4, Y is 2. Okay. 4 divided by 2, we get 2, 10, 8. Oh shit. It's actual 20, 18. Okay. Oh my god.
Let's see if we could give ourselves some practice evaluating expressions.
Oh, I've already
Minus
watched this. I've already
minus
watched
3 with
this.
and n is equal to
Yeah,
1
we're done with
fourth
this video.
is equal to 8.
Setting our example, 1/3 A minus 1 minus 1 half B when A equals 12, B 16, A is 12. Wow, okay. 1/36. No, not really. It's actually 12 divided by 3, 4. 4 minus 3. Wow, 4 minus 1. Minus 0. Okay. 4. So we have there 412 minus divided by 2 is 6 minus 3. We have 3 plus Z is 3. So 15 divided by 3 is 5, 8. 13 minus 5, we get 8. 1/2 plus 11. Okay. Let's do this sec L. I'm just gonna grab some drink. Oh. Why did I write 13? I get confused by that. I hate it. 7 and 4, that's my worst nightmare. 7 plus 4 is like my worst nightmare. Wait, what? 18 plus 16, 3, 19. 2, 4, 2, 4. Or 5, 3 minus 1, 2. 20 minus 12, 8. 4, 1. 11T 1999 plus 3 is 102. Let's actually just do the 1990 first. So let's see, we have 11T 99 minus U 9U11. What the fuck? JK K cube. What the fuck? This is insane. 3 plus J and K plus 12 plus K. I'm getting distracted by some crying baby. um uh 8 and n's 2 plus 7 so 49. 8 minus 4 plus 49 53 61. Whoa, for real? M? What's M? M is 8 divided by 2 is 4. 8 minus 4. Oh shit, I added the bullshit. Ah, hasty. P divided by 4, 2 plus 48, 50. Then M is 5, so we get 50 plus n squared. 4 times 4, 16 divided by 4 is 4 for 4. We have 7 minus 5p is 5 plus 3q plus 21 with the 3's. 9 divided by 3, so we get 3 plus 2h is 12 plus 24. Fraction and decimals, okay. 60 when t is 6, so we get 36 minus 20, which is 16. 32u, 32 divided by 4 is 8, so we get 8. AB, A1, B5, so 5 minus 0.5, B 2.5, get 2.5 still. 8J, J is 1/4, we get 2 minus 1, so you have 1 plus 14, 15. Now 5C, C is 1/5, so it's 1 plus CD, 3 I guess, 4. Okay.
What I want to do in this video is think about how does the value of an expression change as a variable that makes up that expression changes. So let's start with what I want to do in this video is think about how does the value of an expression change as a variable that makes up that expression changes. So let's start with a pretty simple expression. Let's say we variable that makes up that expression changes. So let's start with what I want to do in this video is think about how does the value of an expression change as a variable that makes up that expression changes. So let's start with a pretty simple expression. Let's say we have the expression 100 minus x. We want to know how does this expression change as x increases. As x increases. And like always, try to work it out for yourself. Pause the video before I try to have it go out.
So it goes down,
well,
I guess?
There's a couple of ways you could think about it. You say, okay, I have 100 and I'm subtracting x. So as x increases over here, I'm going to be subtracting larger and larger values. So if I'm subtracting larger and larger values, I'm going to get smaller and smaller values. So this whole thing is going to decrease. This whole thing is going to decrease. And if you want to make it a little bit more concrete, you can actually try out some values there. So you can make a little table here, x, and then what is 100 minus x going to be? And I'm just going to pick some values of x. I'm going to make them increase. Say x is 0, x is 50, x is 100. Well, when x is 0, 100 minus x is 100 minus 0, so it's 100. When x is 50, it's going to be 100 minus 50, so it's going to be 50. When x is 100, it's 100 minus 100, so it's 0. So it's pretty clear here that as x is increasing, I'll just write incr for short for increasing, we see that 100 minus x is decreasing. We see that that is decreasing. Let's do this with a couple of more expressions that have different forms. So let's say that I have the expression, 5 over x plus 5, and x is decreasing x is decreasing. But we also know that it is positive, and even while it's decreasing, it's staying above 0. So we're saying x is staying greater than 0. So in this case, this could be a situation where x is decreasing from 10 to 9, or 1,000,000 to 100,000, but it's staying positive while it's decreasing. Well, let's think about that. We are going to be dividing by smaller and smaller positive values. So as you decrease, as you have smaller and smaller positive values in the denominator, you're dividing by smaller and smaller positive values. So if you're dividing by smaller positive values, this thing is going to get larger. This entire expression is going to get larger as you divide by smaller and smaller positive values. So if that expression gets larger, then you're just adding 5 to it. The whole thing is going to increase. The whole thing is going to increase as x decreases while staying positive. And once again, we can make a little table to take a look at that. So if this is x, this is 5 over x plus 5. And let's see, I'll just try out some. Let's see if I'll go from x 100 to x is 5 to x is 1. So this is clearly x is decreasing. X is decreasing. When x is 100, you're going to have 5 divided by 100, which would be 5 hundredths plus 5. So it would be 5.05. When x is 5, you're going to have 5 divided by 5, which is 1, plus 5, which is 6. And when x is 1, you're going to have 5 divided by 1, which is 5, plus 5, which is 10. So notice, when x is staying positive but decreasing, the whole expression, 5 over x plus 5, this thing right over here is increasing. Let's do one more of these. So let's say that we have the expression, and we'll change up the variable here. 3y over 2y. And I'm curious, what happens to this value of this expression as y
stays the same,
as y increases? Well, as you have larger y's here on the numerator, you're also going to have larger y's here in the denominator. And one way you could think about this is the same thing as 3/2 times y over y. And no matter what y you have here, as long as it's not equal to 0, and actually let's just assume that it doesn't cross 0, because at that point this thing would become undefined. Let's just say that y increases and y is greater than, at that point this is 0. And actually let's just assume that it doesn't cross 0, because at that point this thing is 0. And actually let's just assume that it doesn't cross 0, because at that point this thing is 0 over y. And no matter what y you have here, as long as it's not equal to 0, and actually let's just assume that it doesn't cross 0, because at that point it's not equal to 0. And actually let's just assume that it doesn't cross 0, because at that point this thing would become undefined. Let's just say that y increases and y is greater than 0, just for simplicity. So y is a positive value here, and actually for any non-zero value, you take y, you divide by y, you're just going to get 1. So it doesn't matter what y is. Y could be 1,000,000 over 1,000,000. This thing's just going to be 1. Y could be 5 over 5. It's still just going to be 1. The value of the expression is not going to change. It's just going to be 3/2. So the expression is just going to be the same. You're not going to have any change as y increases, as y is positive, and it increases.
Wow, I don't know. If this is 2, I get 8 divided by 2. With 4. If this was 5, then we're gonna have like 10 divided by 5 too. It decreases. If this is 10, we have 20 divided by 10 is 2. Holy shit, it's just the same. This is 2, then we have 2 divided by 4 divided by 2 is 2. If we have 3, 6 divided by 3. Okay. Check. Cool. Not gonna do the quiz first, let's do this expression value equation. That makes sense, we just cancel the shit out. 1, 3, oh man, let's do the first quiz. Let's go. Oh man, I've only been recording. We're 6 minutes in. Okay, got more. Do some more. What's this? Okay, so 3, 17, 14. The same shit as 7, 2. Yeah, 6 plus 5 eighths. 8, so I guess let's just cancel the shit out. We're left with 5. It's 11. Wow, okay, so let's try not to do the bullshit. 3, we have like 12, 3, 42 divided by, yeah, it's definitely 6, cool. So 5, 8, 40 divided by this. Wow, cool, it's 11. Insane. I like how he just did that. It's pretty cool. Eight degrees. Let's evaluate this. 2, 3. We have our y when y 16. We divide by 3. It's gonna be 9. Minus 3. We have 6 plus 5, 11 as well. Wow, cool. But for real, 6? 18, okay. Same. Evaluate E. So 15 minus 14, okay. Let's keep going. Oh shit, that's a lot of the. Oh my god. What was 7? For real, man?
Alan found 4 marbles to add to his 5 marbles currently in his pocket. He then had a competition with his friends and tripled his marbles. Write a numerical expression to model the situation without performing any operations. So let's think about what's going on. So he already had 5 marbles in his pocket. So he already had 5 marbles in his pocket. And then he found 4 more marbles to add to that. So we can add the 4 marbles to the 5 marbles. So 4 marbles plus the 5 marbles. So that's what happens after the first sentence. He found 4 marbles to add to his 5 marbles currently in his pocket. He then had a competition with his friends and tripled his marbles. So this is how many marbles he had before tripling. And now he's tripling. Now he's tripling his marbles. So we'd want to multiply 3 times the total number of marbles he has now, times 4 plus 5. So this right over here is the numerical expression that models the situation without performing any operations. We of course could then actually calculate this. He has 9 marbles before tripling, and then you multiply it by 3 and he has 27. But this is what they're asking for. They want us to write this expression. What I want to do is think about whether this expression right over here would evaluate the same way whether or not we had parentheses. So to think about that, let's first think about how it would evaluate if we have the parentheses. So if we have the parentheses, we want to do whatever in the parentheses first. And so here we have 8 minus 3, which is equal to 5. So this simplifies to 5 times 8 minus 3. And now we want to do the multiplication before we do subtraction. This goes back to order of operations. You do your multiplication and division first. Well, you do your parentheses first. Then, if you have multiplication, division, addition, and subtraction all in a row, you want to do your multiplication and your division first. So here we're going to multiply 5 times 8 to get 40. And then we're going to subtract 3 to get 37. Now let's think about what this would evaluate to if we did not have the parentheses. So it would be 8 minus 3 times 8 minus 3. So we just have to remind ourselves about the order of operations. The convention is to do your multiplication first. So you're actually going to multiply the 3 times the 8 before you subtract it from this 8 and then before you subtract this 3. So we took away the parentheses, but the order of operations say, hey, do this multiplication first. We could even put a parenthesis here to emphasize that. So this will become
how did you come up with that?
Evaluate to if we did not have the parentheses. So it would be 8 minus 3 times 8 minus 3. So we just have to remind ourselves about the order of operations. The convention is to do your multiplication first. So you're actually going to multiply
16,
the 3 times the 8 before you subtract it from this 8 and then before you subtract this 3. So we took away the parentheses, but the order of operations say, hey, do this multiplication first. We could even put a parenthesis here to emphasize that. So this will become 8 minus 24. So let me write it this way. 8 minus 24 minus 3. 8 minus 24 minus 3. Now 8 minus 24 is negative 16. You subtract another 3, you're going to get to negative 19. So clearly you get very, very different values depending on whether or not you have parentheses.
True.
Express 25 degrees Celsius as a temperature in degrees Fahrenheit using the formula Fahrenheit, or F, is equal to 9/5 times the Celsius degrees plus 32. So they're telling us that we have 25 degrees Celsius. So we could put that in for C here, and we'll get the temperature in Fahrenheit degrees. So let's do that. So we'll get F is equal to 9/5 times. Now for C, we're going to put in 25 times 25 plus 32. And now we can simplify this before we multiply 25 times 9. Remember, this is the same thing as 9/5 times 25 over 1. We can essentially divide the numerator and the denominator of our eventual product by 5. If we divide 25 by 5, we get 5. If we divide 5 by 5, we get 1. So this boils down to 9 times 5 plus 32. So our Fahrenheit degrees are going to be 9 times 5 is 45 plus 32 degrees, or it's equal to 45 plus 32 is 77. So this is 77 degrees Fahrenheit.
Am I supposed to do the article? Oh shit. I'm supposed to do this first. Okay, let's see. With parentheses. What is this about? Oh, okay. Okay. 74? Equivalent to 6. Okay, that's no. Let's see. This is 42 divided by 76. John's mistake. s- 14 to 7. What the money she earned each week. So we have 35, 15 plus 35 times 20 minus. Wait, what? After buying her bike. Oh, okay. Now this makes sense. Which problem could you solve with expression 6 minus 4 plus 2? Plus 1 times 2. Jordan's chopping wood for the winter. For 10 days in a row, he follows the same process. Chops 20 wood. Okay, so this is insane. Pretty hard, but I'm going with A.
A local hospital is holding a round.
What's already I'm done with
Whether
this.
you get
What was Sal finding when plugged the Wait, what? Oh my god. Oh, the cost of 10 tickets. Oh my god. The expression 2m plus 10c gives the amount of money in dollars a dessert store makes from selling M muffins and C cakes. 3 muffins and 4 cakes. 3 muffins, $6 for the $6. A flower store uses expression 2 plus 5 are to burn the cost in dollars of our roses. Roses. So 5 30 30. Yeah, okay, that makes sense. 45 47. Cam is $32. How much roses can you afford to buy? Assume that he wants to buy as many roses as he can. Extra challenge. Explain to a family member, friend, or classmate why the cost of 6 roses is not double the cost of 3 roses. Oh, it's basically plus 2, bitch.
The surface area of a cube is equal to the sum of the areas of its 6 sides. Let's just visualize that. I like to visualize things.
Wow.
So if that's the cube, we can see 3 sides. 3
Oh,
sides are
makes sense.
facing us. But then if it was transparent, we see that there are actually 6 sides of a cube. So there's this one, 1, 2, 3 in front, and then 1, this is the bottom, this is in the back, and this is also in the back. So you have 3 sides of a cube. So I believe what they're saying. The surface area of a cube with side length x, so if this is x, if this is x, if this is x, is given by the expression 6x squared. That also makes sense. The area of each side is going to be x times x, is x squared, and there's 6 of them, so it's going to be 6x squared. Jolene has 2 cube-shaped containers that she wants to paint. One cube has side length 2, so this is one cube right over here. Let me do my best to draw it. So this right over here has side length 2. So that's its dimensions. The other cube has side length 1.5. So the other cube is going to be a little bit smaller. It has side length 1.5. So it's 1.5 by 1.5 by 1.5. What is the total surface area that she has to paint?
The first one is
Well, we know that the
4.
surface area of each cube is going to be 6x squared, where x is the
1.5
dimensions of
squared,
that
ah.
cube. So the surface area of this cube right over here
Seems like
is going to be
2.75.
6.
2.75
And now, let me do
times
it in that
6.
color of
What
the
is
cube.
that?
It's going to
You're
be
gonna add
6 times x, where x is the dimension of the cube. And the cube all has the same dimensions, or its length, width, and depth is all the same. So for this cube, the surface area is going to be
Suck
6
'em up.
times 2 squared.
Freaking
So it's going to be
duck.
6 times 2 squared. And then the surface area of this cube is going to be 6 times 1.5 squared. 1.5 squared. And if we want the total surface area she has to paint, it's going to be the sum of the 2 cubes. So we're just going to add these 2 things. And so if we were to compute this first one right over here, this is going to be 6 times 4. This is 24. And this one right over here, this is going to be a little bit hairier. Let's see. 15 times 15 is 225. So 1.5 times 1.5 is 2.25.
Wow.
So this is going to be, so 1.5 squared is 2.25. And 2.25 times 6. So let me just multiply that out. 2.25 times
13.
6. Let's see, we're going to have 6 times 5 is
13.5,
30.
please.
6 times 2 is 12, plus 3 is 15.
Oh, yeah, I got
6
13.5.
times 2 is 12, plus 1 is 13. I have 2 numbers behind the decimal, 13.5. So it's going to be 13.5.
Wow,
And if I add these 2
37.5.
together, this is going to be equal to the total surface area that she has got to paint is going to be 37.5 square. Well, I guess they're not giving us the units. Well, 37.5 is good, the total area of square units of whatever the units happen to be.
How many videos? Okay.
Evaluate the expression 5y to the fourth minus y squared when y is equal to 3. So every place we see a y here, we can just replace it with a 3 to evaluate it. So it becomes 5 times 3 to the fourth power
No, wow, that's
minus
insane.
3 squared. All I did is every time we saw a y here, I put a 3 there. Every time we saw a y, I put a 3. So what does this evaluate to? We have to remember our order of operations. Remember, parentheses comes first. Sometimes it's referred to as PEMDAS.
6 to 83. 27 times 3 is not 83. 81?
Down. PEMDAS.
Yeah, it's 81 actually.
PEMDAS. P is for parentheses. E is for...
27 times 3. So 2 times 3 is 60. And then 7 is 21. So definitely 81.
Exponents.
Wow.
M and D are for multiplication and division. And they're really at the same level of priority. And then addition and subtraction are at the same level. If you really want to do it properly, it should be P, E, and then multiplication and division are really at the same level, and addition and subtraction are at the same level. But what this tells us is that we do parentheses first, but then after that, exponentiation takes priority over everything else here. So we have to evaluate these exponents before we multiply anything or before we subtract anything. So the one exponent we'd have to evaluate is 3 squared.
3 times.
So just remember, 3 to the first is just 3. It's just 3 times itself once. So it's just 3. 3 squared is equal to 3 times 3. 3 multiplied by itself twice. That's equal to 9. 3 to the third power is equal to 3 times 3 times 3. Or you could view it as 3 squared times 3. So it'll be 9. 3 times 3 is 9. 9 times 3 is equal to 27. 3 to the fourth is equal to 3 times 3 times 3 times 3. So 3 times 3 is 9. 3 times 3 is 9. So it's going to be the same thing as 9 times 9. So this is going to be equal to 81. So we now know what 3 to the fourth is. We know what 3 squared is. Let's just put it in the expression. So this is going to be equal to 5 times 3 to the fourth. 3 to the fourth is 81. So 5 times 81 minus 3 squared. And we have 3 squared right over here. It is equal to 9. 5 times 81 minus 9. Let's figure out what 5 times 81 is. So 81 times 5. 1 times 5 is 5. 8 times 5 is 40. So this right over here is 405. So it becomes 405 minus 9. So that is going to be equal to, if we were subtracting 10, it would be 395, but we're subtracting 1 less than that, so it's 396. And we're done.
Now let's do the practice and then the quiz. Bethany sells roses and petunias. The expression 3r plus 2.5p gives the cost in dollars of our roses and petunias. Oh my god, my body's itching. My body's itching. Body's itching. Okay, so we have 3 times. That's 7 plus 2.5. Oh, I'm allowed to use a calculator. This is cool. I like it. Can do that? Wow. What a weak shit calculator can do that kind of expression. 100 plus 20 times 5. 342 plus 1 times 0.5. There you go. Our rectangular prism with length L with width W and height H has a volume of LWH. What's the volume of prism which is a what's this, 1560? Which problem could we solve with the expression 5 plus 3 divided by 2? I spent 3 on Monday and 5 on Tuesday. No. 5 hours and 3 questions on Tuesday. Let's see. 45 minus no. It's actually the first one. But of course, to be sure, this is 31. Okay. Ben Frank is an electrician who installs lighting fixtures. He charges in dollars his clients 15H plus 40F, where H is the number of hours and it's the number of fixtures. Okay. Let's see. 15 times 7 plus 40 times 9. 465. 465. Thank you for CSS effects. Woo! I guess I can stop here. Yep, I can stop here. I'll finish this in the next video. Yeah, it's quite fast. I actually just tried for 2 hours. Okay, my hair sucks. I need a haircut. Okay, this is good for now. Getting sleepy as well, so yeah, 90% for that part. So let's see how much I increased. 77. Let's see. Got 83.35 Apple. Then missions 24%. Okay, so that's part 18. I'll do part 19 tomorrow. Bye.